All right, before we get to our next example, I want to introduce a related rates strategy. So this is a strategy for approaching related rates problems, and it has a handy-dandy acronym, DREADS. And this is a nice mnemonic for remembering how to approach things. So let's go through the letters of this acronym and talk about what they are. These are the steps in a process you can take to approaching related rates problems. So the D stands for diagram. So the idea with that is draw a picture. And what you want to do is label that picture with all of the constants and variables. So if there's any measurement, if there's any distance or angle or area or anything like that which is a constant in the situation that's described in the problem, you should label that constant. But if anything is changing with respect to time, then make sure you label it as a variable. Okay, even if it says, like in the previous example, when the radius is 12 centimeters, that's not saying the radius is always 12 centimeters. That's just used to specify an instant. So that would still be, the radius would still be a variable. So that's diagram, draw a picture. Then R stands for rates. And the idea there is to identify all of the both known and unknown rates in the problem. Now, that doesn't necessarily mean like you should think of all rates, all the possible rates that you could even think of, but what you should do is identify which rates are known and which rates do you want to know, and then write those down. Okay. The next letter here, E, stands for equation. So what we want to do there is come up with some equation that involves the relevant rates. Actually, the relevant variables. That's what I meant to say there. There may be other variables, like say you have a triangle, you've got all three sides and you've got all three angles, but it could be that you don't care about the angles and you just want an equation that involves the sides. Or alternatively, maybe you do care about one of the angles, and so you want something that involves that angle as well as another side, or whatever. There's different equations that you could come up with that involve different variables, and you want to select an equation that involves the variable you have information about and the variable that you're trying to find, that you're finding the rate of change in, usually. So the next step in the process is to differentiate. So that means differentiate with respect to time, the variable t, on both sides of the equation. So everything's differentiated with respect to time, and you want to perform all those derivatives. Then you substitute. Substitute. There we go, I can't spell. Then you substitute. What you're going to do is plug in, everyone loves that term, right? Plug in all the known rates and values. So this is the moment where if some moment in time is specified by the value of a specific variable, like in the previous problem when we said r was equal to 12 centimeters, this is the moment where you substitute it in that value. After you've differentiated with respect to time, then you substitute in the instantaneous value that identifies a moment, as well as any known rate values that you came up with and you wrote them down in step 2 up here. The last thing to do is to solve, and you're going to solve for the desired rate, whichever rate you're trying to find. Okay, so DREADS. I'm going to use this process, use the DREDSS like step-by-step process in the next couple of examples.